So welcome back to a lesson for today. We'll build from our last lesson that we did. We solve more examples to explain then to your understanding of everything that I want you to get and then to understand. So our last lesson we talked about the special angles. Under the special angles we talked about some ratios under sine, cos, and tan. And so we'll go through some examples to build our understanding in this lesson. So I will take a first example in this our very lesson. So this will be the first example. If cos theta equal to 0.6, find tan theta for 0 degrees less or equal to theta less or equal to 90 degrees. So we have to find the value for tan theta from this our first example. Now we have cos theta, which is 0.6. Now we know that, so let's say in our solution cos theta is 0.6. Now 0.6 is the same as 6 over 10. When you divide 6 by 10, it will give you 0.6 because the 10 is having one decimal place. So we can still reduce it. A number will go into 6 at the same time it goes into 10. So I can use 2, which goes into 6, 3, and 2 goes into 10, 5. So cos theta, which is 0.6, is also the same as 3 over 5. Now to be able to find the value of, or the value for tan theta, we can draw a right-angled triangle. So this will be our right-angled triangle. We can name it as A, B, and C. It is cos theta. So I can write my angle at B, which is theta. Now cos theta is equal to adjacent over hypotenuse. From this diagram, line AC is opposite, AB is adjacent, and then the longest side, which is BC, hypotenuse. So this side will be 3. Since cos theta is equal to adjacent over hypotenuse, and then line AC will also give us 5. Now to be able to find tan theta, we have to find line AC. Now to find line AC, we can apply the Pythagoras theorem. So you can say that by using Pythagoras theorem, the longest side is AB. So now I'll make it very simple. So line AB will be equal to square root of line AB or BC square equal to line AB square plus line AC square. Now since we are finding AC, we can make AC the subject. So this will be line BC square, then you transpose AB to join BC to be minus line AB square equal to line AC square. So in this case, in place of BC, we substitute 5. So this implies that we have 5 square minus brackets. AB is 3 square, which is equal to line AC square. 5 raised to the power 2 will give us 25, meaning that 5 multiplies itself 2 times, minus 3 to the power 2 also give us 9, meaning that it is 3 multiplies itself 2 times. So we have 9 equal to AC square. Now 25 minus 9 will give us 16, which is equal to line AC square. We are finding AC, not AC square, so we square root both sides to remove the square root. So square root of 16 will be equal to line AC. Square root of 16 will give us 4. Now anytime you square root both sides, you get 2 values. So you can also make it plus or minus equal to line AC. Now since, so you can still maintain it as our 4. So therefore line AC equal to 4. So line AC is now 4. So now we can find what we are asked to find from the question, which is tan theta. So now tan theta, which is equal to opposite over adjacent. Now from a triangle, the side of opposite is AC over the side of adjacent is also AB. So what do you have then? In place of AC, so you say tan theta equal to AC is 4 over, then AB is what? 3. So we have now tan theta equal to 4 over 3. You can still further simplify it. 3 goes to itself 1. It goes into 4, 1 whole number. Remember 1 over 3. That is the value for tan theta. We can still move on by solving another example. In example 2, we take another question, which is if sine x equal to 12 over 13. Whose 0 less or equal to x less or equal to 90. Find the value of one plus cos square x. So now we have been given sine x, which is equal to 12 over 13, whose, that is the range given, is 0 degrees less or equal to x, and x less or equal to 90 degrees. And you have to find the value of 1 plus cos square x. So in our solution, it's not different from what we did earlier on. It is the same thing. So what we do is that since we have sine x equal to 12 over 13, we have to find cos. So you have to use sine x given to draw a right angle triangle so that we can find cos x. So this will be my right angled triangle. And I'll name it PQR. Now the angle will be at Q, which is x. Sine is equal to opposite over hypotenuse. So the 12 is opposite. So line PR is our 12, which is the opposite. Then QR will be hypotenuse. That will be 13. Now in this case, we apply the Pythagoras theorem. The longest side is the hypotenuse. So what is going straight, 13 square equal to 12 square plus, we are finding line PQ. So line PQ. 13 square will give us 169 by punching the calculator, which is equal to 12 square will also give us 144 plus line PQ. Now we are having 169, which is equal to 144 plus line PQ. Now we have to group like terms. We transpose 144 to join 169. So this implies that we have 169 minus 144 equal to line PQ. Now to find PQ, you have to do subtraction. So when you subtract 144 from 69, it will give you 25, which is equal to line PQ. The PQ is supposed to be squared. I didn't bring it, so line. To be able to find PQ, we have to remove the square root. So you square root both the square. So you have to square root both sides. So this and that. So the square will cancel the square root. So you have line PQ equal to square root of 25 will give us 5. So now line PQ will now give us 5, either in centimeters or in meters. And so we can now write cos x as, you go back to the diagram, cos is equal to adjacent over hypotenuse. So where we have our adjacent, it is 5 over the hypotenuse is 13. So cos x is now 5 over 13. So now going back to the question, we are asked to find 1 plus cos square x. So now we are to find the value of 1 plus cos square x. So now since we have cos x, which is 5 over 13, we have to do substitution. So we have 1 plus, in place of cos x, we put 5 over 13. So bracket 5 over 13 squared. So 1 plus, the square here is affecting 5 at the same time the 13. So 5 squared will give us 25 over 13 squared will also give us 169. Now what we have to do is to find LCM. We have to find LCM. So this implies that we have 1 over 1 plus 25 over 169 all over. We have 1 and 69. So we have 169 to be our LCM. So 1 goes into 169. It's 169. Plus 169 goes into 169, 1 multiplied by 25 is 25. So we have to add it. So 169 plus 25 will give us 194 over 169. we can still go further by punching a calculator. 169 will goes into 194 1. Remember, 25 over 169, meaning that 169 plus 1 or multiplied by 1 is 169 plus 25 will give us 194. So this is our answer for the question given, which was 1 plus cos square x. Okay, so we have gone through 2 examples. So what I will do is that I'll give you one assignment for you to try, so that when you meet in our next lesson, I'll look at it and then we solve. So assignment 1. So this is assignment. If tan x equal to 1 over square root of 3, find cos x minus sine r such that (0 degrees less or equal to x less or equal to 90 degrees. This is supposed to be x. So this is your assignment for today. So in our next meeting, we have to go learn all that we have learned so far, go through all that. If you have any problem, visit me on my line. I give you my email address and the day you can meet me, so that in our next lesson I will take you through some test drills, that is examination. So I want you to be very serious, prepare yourself very well, so that when you meet, things will go well with you. Have a nice day and have a fruitful weekend. Thank you.